welcome to the Bell Vista Radio Club's July virtual meeting. My name is Tom Northfeld, call sign W5XNA, and I am the current president of BVRC. Thanks for joining us tonight. I hope you and your family are doing well and in good health. The Bell Vista Radio Club currently has around 120 members and growing. Because of the COVID-19 situation and in the concern for the health and safety of our members and the general public, we have not been holding in-person monthly meetings and did not organize a field day as in the past years. Tonight's meeting is another in a series of virtual presentations by members of BVRC. The following is a list of members that have enthusiastically agreed to be presenters for tonight's meeting. They represent the lifeblood that all amateur radio clubs need to be successful and growing. I believe you will find the presentations interesting and informative. We have with us tonight Tim Moore, N5KWL, and John Williams, K5DVT. I refer to them as the Batman and Robin of amateur radio in Northwest Arkansas and the surrounding region. Their presentation is titled, Things You Wanted to Know About Repeaters But Were Too Afraid to Ask. We also have two show and tell shack tours tonight. Scott Branyan, W5AAJ, who has just recently achieved major accomplishments in our hobby, upgrading his license to Amateur Extra and achieving the DXCC Award. And last, but certainly not least, Glenn Kilpatrick, WB5L, BVRC President Emeritus, and the 2018 ARRL Delta Division Ham of the Year. I want to thank this fine group of presenters in advance for their willingness to share, and a big shout out to Wayne Patton, K5UNX, for putting this all together. Now it's time to sit back and enjoy.
Okay, here we are on Gobbler's Knob, and there's the house, and for those who have heard plenty about it, there's the new shop. Let me show you a little different view. Here we go, the new shop. Now, I'm going to get a new roof, so that one is hail damaged. But anyway, as we go in, you'll see it's just about all done. There's the redbud tree that Jesse gave me, and it's working. It kind of withered a little, but I think we'll be all right. I keep the water hose on it. Thanks, Jesse. Going in the shop, it is a mess, just like everything else I got. Non-finished work in progress. So there's the beam I'm going to put up, and Mama's car. So let's go on down. So, like, y'all excuse my mess. I mean, I live here, and this is this is me. Unfortunately, I hate to say, but there's always some project going on. You know, for instance, I'm painting the brick walls on the back. But anyway, we're going into the basement to the ham shack. Now this is in a somewhat state of flux. This area over here is going to be my electronic workbench eventually, and all these tools are going to the shop, and this will be some cabinetry. And then going into the basement shop, you'll see there's my SB1000 and my TL922. I just got it from Dennis, K4AFE. And again, this is a mess. Okay, this is, we'll just kind of walk around the shack here in a circle, and you get to see what I see when I'm down here in the man cave, commonly called the basement room. Like I said, I need to clean, but this right here is the APRS system. It's run on a Raspberry Pi, and there's the radio down below the monitor, and the power supply on the left side, and the little Raspberry Pi is running the PK232 down on the bottom with a keyboard. And there's my 2 meter setup, 2 meter 440 Kenwood 790. This is my Helicopters SX99 from Bob Heil. Had a great conversation with him that day. Moving around, I got a bunch of stuff. Some of it works, some of it don't work. But there's my little Hercules amp there I got from Ron, K5XK, and my tuner, my flex radio, and down below is the Kenwood 690. You can see it's all these shelves I built down here. We just finished the round table. That's why what you heard when I first came in the shack. So over here is what I consider my sort of novice compared to what I've been seeing, especially over at Steve's house. My little electronics workbench area, and this is where I have a lot of fun playing with electronics and stuff. But all this kind of stuff in the basement, and then one of these days that all that electronic stuff's going to be over here at this workbench, and microwave, coffee pot, which I gotta have a coffee pot. It's all going to be over here under some cabinets that I'm building. So that's pretty much it. The walk around the ham shack, and this is where I'm at most of the time. I'm on the radio. Power supply is down there on the bottom, and work your way up. Amplifiers, radios, tuners at the top. That's kind of the way I do it. But this is the WB5L ham shack, complete with the new ceiling. Well, it's not so new anymore, but anyway, it's a work in progress like everything else I have. I always seem to get the sun when I stand here in this picture, but the tower currently is 56 feet, and I've got a couple of extension arms with some dipoles, 40 meter and an 80 meter dipole, and of course that's the 2 meter on top. I don't know if you can see all that or not, but way on up there, the top of that antenna is about 80 feet. 2 more tower sections are going on there, along with that not 2 meter, well, this 2 meter beam, that's a 440 reflector for a TV I was playing with, and 2 meter beam I've got set up and working now. But also the Mosley TA33 that you saw back in the shop, and that will be going up there. So the whole thing will be 70 feet to the top of the tower. Runs underground over to a pipe going through the wall. Hopefully I'll have a pipe going down to the base of the tower as well. I've got some hard line to run. But that's the antenna situation as we have it. I've got a little storm antenna. I call it a storm antenna. It's just a mobile antenna on the chimney for the APRS. And anyway, there's the antennas on top of Gobbler's Knob. Here's my new QSL card from Greg Doty and 5RGD, who does a fine job making me official Gobbler's Knob QSL card. You may have one already. If not, you may get one. So, as Don prescribed, he said I probably should put myself in there. So here I am, and this is where I'm at most of the time, sitting here at the ham shack. This is my PR 781, and I don't know if you can see it. This mic right here, it hooks to the 790, and it talks on 2 meters. And this is where I spend a good bit of my time, and it's just been a great hobby to have ham radio. All this stuff keeps me out of trouble. I put it that's what I tell my wife anyway. So 7-3, and I hope you have a great Father's Day. Father's Day is today, and spend time with your family, because they're more important than you realize. So talk at you later.
Well, thank you, Tom, Wayne, and crew, all the officers at BVRC for organizing these online meetings. They've been very interesting to watch. I've enjoyed them thoroughly. So thanks for inviting me to share my ham experience. I've been a ham for a little over a year, and I was licensed in February of 2019. I got my first radio, which was a dual band 2 meter 70 centimeter rig in March. In June I got my HF set up, and that was a really good time to get on the air. I was licensed tech in general, and so I had my HF privileges, and I took advantage of them just as soon as I could. My Elmer, Trent Fleming, who lives in Germantown, Tennessee, N4 DTF, he's been great, great advisor, and even though it's been a distance relationship, he and I are friends and have a similar fishing interest. And so he put the burr under my saddle and the bug in my ear, and got me going, pursuing my ham license. He recommended a G5 RV, which I have on my property. I've got enough room for it here, about 105 feet or so in length. It slopes. I've got 35 feet on the southwest end. On the northeast, I've got 50 feet. So it averages about 35 to 40 feet off the ground. And it's been a good performer for me, and that was a good piece of advice he gave me. It works for my situation, so I've really been enjoying the G5 RV. But the other thing I'd like to do is install a 40 meter beverage. I think that might really help with my reception of some difficult to hear stations in Europe. And also elsewhere, but Europe seems to have a lot of interference going on, and I know I miss a lot of comebacks from stations over there that are weak signals to me. So I think a beverage might help in that regard. Let's see, I'd like to go over the radio equipment I've got here in my station. This is the Thursday before field day, so I'm just meeting outside here. The mornings have been very nice this week, and so I wanted to take advantage of that, and at least, even though I'm on shore power, set up outside and play with it outdoors some. I don't know if I'll be able to actually do it on field day because of family obligations, but I'll try to get on the air at least from inside. So the setup I've got here is a Daiwa power station, power supply, 30 amp. That supplies power to my Kenwood TS480 SAT version, which is the 100 watt version. I got that radio because it has some portability to it. I know some people even set it up in their vehicles. We have a small teardrop camper I hope to use it in and bring it along on some trips. But I really like the radio. It has knobs and dials, and rather than a lot of menus. And I think for me, that was the perfect start. I've always been interested in listening to shortwave, fidgeting with those dials, so that was a big attraction to me. So let's see, power supply, radio, power meter. I have a diamond little power meter here that's pretty portable that I can take with me, and I find that to be a very useful tool. If you don't have a power meter for your station, I advise you to get one. It just gives you a peace of mind about that antenna is getting the power to it that it needs, and the radio is performing right. Just a lot of pluses. It gives you instant feedback on that. I have a SignaLink USB connector for my laptop for digital modes. At first I just ran it directly to the laptop and used it just to manually tune on my radio for FT8, and that worked. So I finally got a serial interface to the data port of the radio. It was a little more involved getting it set up with the older radio and fidgeting and learning the steps and the procedures. One of the big things was I was getting rig control errors because I was trying to run the software and I didn't have the radio turned on. So you got to turn that radio on first before you start the software. It's got to see it to know that it's connected. So just working through some issues like that took me a while, but everything's working smoothly now. I have a set of headphones, just the Kenwood HS5 headphones. They're pretty uncomfortable, but they do the job. And if I adjust them and play with them, I can get them to fit where they're not painful on the ears. So getting the right headphones helps. I'll probably upgrade to a set of Heil headphones at some point. That's kind of my equipment. Just a Windows laptop running WSJTX software for the FT8 and FT4 modes. I also use FL Digi, listening on CW. I'm learning CW now, so that's been helpful. Trying not to let it become a crutch, but I do like listening to the weak signal stuff, and so it really helps pick out some of the weak signal CW that I can't audibly hear all the time. My experience getting on HF was very good. Last June, it was the perfect time of year to get on because there were a ton of special event stations. It started off with the D-Day anniversary, and I was able to pick up several D-Day special event stations, mostly in the States, but I did get to hear some in France. They were pretty busy though. And then after that was the 13 Colonies special event, and I contacted the 13 original colonies of the U.S. With their special event stations. That was a lot of fun, and getting the QSL cards was pretty special. And then there was the anniversary of the moon landing. So 3 major special event stations, special events going on last summer. And by September, I had earned my Worked All States Award. So that was a lot of fun, a lot of joy. One interesting story was on my 50th station, which was Hawaii. I had told a friend the day before that I had contacted Hawaii, but I wasn't able to get through. And I said there was no joy that day. And the very next day, I got through to a station. As luck would have it, his name was actually Patrick Joy. so that was pretty cool, picking up joy, literally and figuratively, for Hawaii on that Worked All States Award. After that, I worked on DXCC through the fall and winter months and into the spring. I got that award in April on mostly FT8, but I did do some mixed phone SSB connection contacts for that. That was a lot of fun because I got to see the seasonal changes in propagation from end of summer into the spring. And that's pretty interesting. So you start looking at the propagation and how that affects you being able to contact time of day and so on and so forth. That's a lot of fun to explore and get to learn. And then April, I made my first CW contact with a special event station. I contacted them on SSB, digital, and CW. The Louisiana Purchase W5L, I think it is. So now I've got, I don't know, 12, 15 CW contacts. I'm working on Worked All States triple play. And that's a nice break from the DX. Sometimes I get tired of DX. Sometimes I get tired of the local stuff. So it's good to switch back and forth. And the CW gives you another aspect of radio to enjoy. So that's kind of where I've been, and it's been a whirlwind tour here of ham radio this past year for me, and I'm looking forward to just settling back and just enjoying the contacts I make now. No pressure. I'm not going to be a contester, and I'm not going to be a big DXer, but I'll just do it for when I want to do it and as a hobby and for the fun of it. No way am I going to lose 8 hours sleep staying up for contests or making DX contacts. But I can understand people getting involved in that. There's some adrenaline rush in it, for sure. So a big shout out also to Paul Dixon, who got me, advanced me in my learning of FT8. He got me set up to do Fox and Hound. And I called him. I was trying to contact Chad in Africa, and on the phone he got me going on FT4 or FT8 Fox and Hound, and I contacted Chad in Gabon while I had him on the phone live. So that was a lot of fun. Thank you, Paul. That was a very memorable experience to have and share with you. So that's all I have for now. Thank you for the opportunity to share. Thank you, leadership, for all you do for the club and particularly for the help that you've given to this ham. 73 for now. Whiskey 5, Alpha Alpha Juliet, signing off.
Primarily in repeater systems, we're using commercial equipment. So this type of antenna right here was originally made by a company called Dipole Products. And they've been bought and sold so many times that I honestly don't know who make them now. But this is a stacked dipole antenna, exposed dipole antenna. All these little loops are basically dipoles, and there's a total of 16 on here. And for you guys that kind of look at antennas, base antennas, and look at gain figures, this little antenna, they actually, when they build them, they measure it before they ship it out, and you get an actual live chart of the gain on the antenna, so you know you're getting what you're paying for. And these things, by the way, run around $1,400, $1,500, $1,600. It's pretty pricey. But this thing is close to 20 feet long, and the true decibel gain on it, and its DBD, is actually a more realistic gain figure, not the dBi that you see on a lot of antennas. This is a 9 dB gain antenna. So basically what that does is an antenna with no gain, the RF just kind of goes out broadways, okay?
Like a light bulb.
Like a light bulb, that's right. And when you got a gain antenna, what it does is because they're all phased in such a way, it literally it sends that beam out more on the horizon than it does up in the air. All that RF is not wasted up in space.
Like a pancake or a CD.
That's exactly
Yeah.
right. That's exactly right. John is my sidekick here. He's also our videographer. But we have to use these things. I have been known to use, John and I have used antennas that are basically amateur grade for our little home projects and stuff like that. But on a repeater that we want to work better than a commercial repeater, we use these kind of antennas. And what's so nice about these is they're built. There's no adjustments that need to be made, and they just work. And this one is called the DP224. And this is the UHF version.
Oh, 420. You said 224.
Did I say?
Yeah.
Thank you, John. And that's another reason John here to correct me. This is the DB224, and it is the UHF version. Okay, that's like 444. The other decibel antenna that we like to use is the DB224. Is that correct? Or 240?
A DB420 is this UHF
420
one.
is this one.
A 224 is the VHF.
224 is the
VHF.
version.
Yeah.
Right. Oh, help us all here. And it's actually a little bit shorter than this one, and it usually has about 6 decibel of gain because it's only got, the elements have to be bigger physically because of the frequency. And there's usually typically 4 of those, and they're all offset in different directions. But these are good antennas. They last a long time. We do have to occasionally bring them down, even though they're aluminum, and loosen these little elements here and get hardware cloth or steel wool and polish these, because as water gets in here, we do develop little joints of rust and everything between this aluminum, and it can cause something that us guys that build repeaters absolutely hate, and that's called desense or desensitization, where you've got water in here, you got dissimilar, they're similar metals, but we get little oxidation places in there, and they actually start working like little diodes. And when you energize these little diodes, they put a spectrum of energy out that can cause interference on your reception. So that's one reason hams don't like these things, because you do have to take them down probably every 10 years or so and polish them up, put them back together, make sure you get everything aligned just the way it is.
Or you're supposed to take them down every 10 years.
Supposed to, exactly right. And we're kind of lazy. And I tell you, I'm getting to the point where I don't like hanging these things on towers. They're really hard to get up there. We have to use a gin pole a lot of time to get them up because they're so big and handy. But they're awesome antennas. So if we've got a repeater that we want to work well, we use these things. In fact, the site we're at right now at Dodd Mountain, there's one of these mounted at the very tip top of this tower. And it's getting old, and there's another one up there mounted right next to it. It's getting old, and we're starting to get descent. So what I've done on this, and this is the D-Star, we're actually using 2 of these now going through the duplexer. So one is energized, one isn't, and we don't get descents. And we'll talk about descent somewhere else in this program too. It's a dreaded thing when you're building repeaters.
Right. As a sort of testament to the quality, I mean, when you say, what do you say, 1,400 for these?
Yes.
They really are. I mean, this is double wall. This is 2-inch pipe. I mean, I can't even reach my hand around it.
Yeah.
2-inch double walled pipe for this main section. And then somewhere right about that roof line right there goes into, I think, single walled. But this cable, this is ultra thick. Let me focus there. Ultra thick, super size. I believe it's like a form of 213. But it's comprised of 75 and 35 ohms impedance to get the phasing right. But also what makes these antennas super heavy is that this is actually inserted with glue around the braid. So if water was to ever ingress by like a bird nicking on the insulation, water can't get in there and start forming little diodes, which can cause the descents like we just talked about. And, as a testament to, how well these things work, that's why there's, easily half a dozen still in the air here that work pretty well. Probably 20, 30 years later?
Oh yeah, some of these antennas have probably been up there for at least 20. John, let's lay it down. We'll show all the thicknesses in the base part
Sure.
of this. Okay, antennas are important. I'm not going to really say what's the most important in a repeater setup. Really, everything's important. And if you want to do it right and have it set up right and perform correctly, you got to do all these things. But getting the signal from the repeater to the antenna, and of course, the signal from the antenna down to the repeater, we have to have good, solid feed line that will get it down there with minimal loss. Now, remember, on a repeater, we're transmitting and receiving at the same time. And even though the duplexer does a lot of that magic, and we'll show some of that later, or we may have already shown it in the video, we'll talk about all that. We still have to have good feed line with good connections and very, very low loss and continuous correct impedance throughout the whole thing. This is what's called hardline, and you can't really see it because it's coated with a plastic material, but it is a solid tube of copper, and it's corrugated. It's filled with a dielectric foam, and then it's got a solid connector or solid center conductor in it that is copper clad. And there's special connectors that screw on these, and actually, and this is what we call 7/8 inch hard lines. Now, if we look, let's look over here, John. If we look over here, this is 1/2 inch, and there's another 7/8. These are good, okay, for VHF, but for UHF, we really like using the 7/8 inch. So let's go back over here, and as you can see on this one, we have a lightning arrestor too. And we did a bad thing here. We had to adapt it. But these connectors are really solid. If they're put on correctly, you could actually pull this heavy hard line up the tower with the connector, although it's not advisable we do it. And you can see also we've got a lightning arrestor here and then another little section of cable. So let's talk about the cable that we use on the repeaters. It's a cable called RG142. And this stuff probably runs around $6 or $7 a foot. It's got...
So it's not your CB coax?
No, it's not CB coax. No pun or in fun of CBers. I think we probably all were one at one time. But this is actually a high isolation cable is what they call it. In fact, DX Engineering, that's what they call it. But this is commonly used in repeaters where you're working with two frequencies. You've got a receiver listening at the same time that the transmitter is transmitting. So separation and isolation is always important. This is probably the highest isolation you can get that's flexible besides hardline. And this is what we run between the duplexer and the radios and the duplexer to the lightning arrestor and things like that because they're flexible. Now, as far as high isolation, you can't get more isolation than you can from hardline, but obviously hardline's kind of hard to run from all our little components that we've got in a repeater. Another thing that we usually always use are in connectors. It's got a gold center pin, and they're silver, literally silver connectors. The good ones run you probably about $9, $10, $11, $12 a piece. And they're crimp on. We always use crimp on. But one thing I failed to tell you about this RG142 is it has a steel center conductor that is coated with a very thin coating of silver. Then it's got the dielectric. And then it has a silver coated shield that in its own right is 100% shield, and it's silver coated. And then there is yet another shield. So there are two braided shields around here. So the whole idea of that is no RF slips out of here. Now this stuff is lossy, but it's worth using. And when you start connecting your repeater components together, this is an absolute must. I've gone to sites where people are having all kinds of problems with a repeater, And 9 times out of 10, make them up new connectors like this, the cables out of this cable. They don't know about it, and make it, and just, it's like magic. Quit smiling at me, John. But it'll solve all their problems. So that's the cable that we use.
And a little shout out here to, let me see one of those connectors. W5 SWL down there near Mulberry, down by Alma and Fort Smith. Shane told me about him. He provides us with a lot of good quality silver connectors that I'll use on repeaters any day. And it's nice to support local businesses. Just a little plug for him. Tim, what's that hunk of metal over there holding down the building?
Well, this is a little floor rack right here. And I really like these things because you can nicely mount all your components in the rack. And what we're looking at right now, we're at Dod Mountain again, and there is no repeater on the NWA link system on Dod Mountain. However, this is an affiliated repeater, and this one is D-Star. And what we've got here is, starting with this component right here, is an analog Kenwood repeater. And these things are just fabulous. And they'll do narrowband and wideband. And this one actually is running in wideband mode. This is the all-magic duplexer right here. This is an old one made by Dipole, the same people that made those antennas that we have or will talk about. And we're gonna go in great depth on these duplexers. Okay, actually it is a duplexer, and I'm real bad about saying duplexers because it has multiple cavities on it. There's 2 for the transmit side and 2 for the receive side. And this is what does all the magic. And let me tell you what's going on here on a repeater. And I may have to look at my cheat sheet here for my numbers. Bear with me just a minute. Here it is. Okay, this repeater right here transmits, and it's transmitting in D-Star, which is a digital mode of communications. Actually sends 1s and 0s out over the air. But this transmitter transmits at 25 watts. That's what the power setting is set to. Now this particular one has a preamplifier for the receive. A lot of times you can't get by with that on a repeater, but we are on this one. But here's what's going on. Let me kind of give you some numbers here. When you translate 25 watts, that is 35 volts of RF power, okay? Now, at the very same time that 35 volts is going up that antenna is trying to receive a signal that can be as low as 0.25 microvolts.
That's a lot of zeros between the two.
There's a lot of difference in there. And that's why doing repeaters is a little bit more difficult rather than just running your transceiver where you transmit and then you unkey and then your receiver listens. So we're doing this simultaneously. And that's where 90% of the challenges come in on repeaters. So that, to me, that's just magical that can happen. And it's the duplexer that makes it happen. And basically a duplexer is just simply a filter. It's 2 kind of filters. It's a pass filter, and there's basically 2 sets of them. A pass filter, and then it's also 2 sets of reject filters too. They'll reject one out. So, I call it magic, and it really is. Early hams couldn't afford to buy these things, so they built them. And I think John has built one too. And they built them out of all kinds of crazy stuff. Copper pipe,
trash cans, beer kegs,
and all kinds of
iliacs.
Stuff. And back in the day, just about all the repeaters were VHF repeaters at that time. There weren't too many UHF repeaters. Now these are UHF, and this D-Star repeater is UHF.
So you mentioned D-Star, but you also said that that's an analog repeater. So what magic box connects the two?
Well, glad you asked, John. It's cool. There is a little device. Used to, if you wanted to put up a D-Star repeater, you had to go to ICOM and you ordered this. You picked your frequency, UHF. The UHF repeater for D-Star was about a mere $1,400. But that wasn't all you had to buy. You had to buy an ICOM controller. which was probably another $1,400. Okay, it had no lights on it. You didn't even know if the power was on or anything. And a lot of smart people put together some computer programs and hardware and came up with some things that are just absolutely fabulous now, especially for people who like to dabble in digital repeaters. And one of the boards, it's kind of come up, but right now, the biggest, best is a board called the MMDVM board, and that stands for Multi-Mode Digital
Voice modem.
Voice Modem.
Yeah.
And that's exactly what it is. It's actually a modem that changes the analog audio to ones and zeros. Okay, and if John will get a close-up here, you can see this is an Arduino Dude in a nice little plastic case. The MMDVM board, which is actually your modem, is right here. Now this little thing handles the voice processing and all that kind of stuff, and when it's ready to go, you see these little flashing LEDs right here. Now these will do D-Star, they'll do DMR, they'll do the NS, what's the
NXDN from
NXDN,
Yeah.
the Kenwood flavor.
P25.
P25, which is the public service mode, and then last but not least is the Yaesu System Fusion mode.
Right.
Okay, they'll do them all, but we have found out that it's not good to allow them to run in all modes like that because nobody really gets to use it.
Everybody's fighting because they want to play on their favorite
That's
mode.
right. So, because that's why it's best to put just a D-Star or a DMR or any of that. But this changes all that to ones and zeros. And this is a little Raspberry Pi right here. And as you can see, it's hooked up, it's got an Ethernet port on it, and it's got a little, what do you call these little cables, John? USB.
Yeah.
Like a regular USB to a micro USB that goes to the Arduino. This acts as a gateway to the world. And if we kind of scan on up here a little bit.
Oh, is that your 100 megabyte fiber connection?
Well, no, we don't have fiber
Oh,
here.
dang.
We've got our own internet up here. This is our switch. Okay, and you can see we've got 4 ports. Right now, we've got one going to my house, one going to Winslow whenever we get it back on the air, and Highway 23. And that's the source of our World Wide Web connection at Highway 23.
Wait a minute. Did you mean to tell me you're sending microwave Wi-Fi from here down to Brentwood?
You are correct.
Wow.
So we've got our own little network here, and I tell you, everybody's invited to play along with this stuff too. These are lightning arresters right here because all the electronics, the radios, the modems, and all that for the microwave are mounted up on the tower, and there'll be some pictures of those dishes up here. This is our site router, and we actually have another little device hooked to this site router that transfers it over to another building, our internet connection over to another building up here on Dog Mountain that we're going to have to do a little work on. It's not working real well. So this is what we call a homebrew D-Star repeater, and they work way better than the expensive icon repeaters, and I can tell you that from experience. D-Star is an awesome mode. I tout it and pull its leg all the time because I love doing that kind of stuff. Also here we have it's actually a solar charger, and the reason we have this is we've got little computers running and all that kind of stuff, and we don't want nasty stuff coming over the power line and little interruptions or blips or power surges. So this little solar controller is literally being fed with a power supply, not a solar panel. But it's got positions on here for the load and the battery. So it's keeping this battery charged right here. These little devices that are up on the tower use PoE, and that's power over Ethernet. This switch provides the power to those devices on the tower, the little radio modems and all that stuff that are up there. So this is a 12 volt to 24 volt step up. I guess we could call it an inverter. And that powers all the devices up here. So if we get an interruption, it won't last long, but this battery will at least take care of the little nicks and everything and little blips in the power. and it just protects our delicate little Raspberry Pis and all that kind of stuff. And I guess we saw the lightning arrestments over here, because that happens quite a bit. A tower gets a strike, and it'll come down the Ethernet lines and do that. Speaking of feed lines and hard lines, if you look over here where our cables come in, that is the cross section. What is that, John? It's bigger than 7/8.
What is it? 1 1/4?
Maybe
1
that's-
5/8?
yeah,
No, I bet you that's 1 5/8.
That's probably 1 5/8 hard line that was cut, and we're literally running our cables through the center of that hard line. It's just it looks just like it on the other side.
Those heliaxes are so big that not only is the center conductor, it's no longer solid, but it's actually a pipe itself,
That's
like
correct.
the outside conductor.
That's correct. Yeah, the heliax, this side right here, the 78s that we talked about earlier, or later, not sure on the sequence, the center conductor is actually hollow, because all you guys know about the skin effect for AC. When you get up on high frequency, all that energy just travels on the outside of that conductor.
So it doesn't make sense to have this huge,
That's
thick
right.
cable when you can make it a pipe.
Heavier. It's heavy enough as it is. But anyway, this is our D-Star repeater, and this one is called KG5JPJ. It's connected with a brother or sister, KG5JPK, in Eureka Springs.
And hopefully another sibling too, eventually.
Yeah. And eventually it will go up to poor old Winslow that is off the air right now. It has the D-Star. That particular one actually uses ICOM equipment. And we learned on that one that the homebrew D-Star repeaters work actually better than the ICOM. So from here on, it's all homebrew repeaters. And actually, there's a better type of modem that we use now besides this one. And if anybody has any questions, they're welcome to call me. If anybody's interested in D-Star. Yeah. So that's what we got here at Dodge Mountain. Now, John has some 6-meter stuff here. John, I don't know if you want to talk about it.
I will in just a moment, but do you want to tell them about the time you had the 820 up here and what would happen when it got cold in the wintertime? How it would drift?
Yeah. The good thing, this is a fairly mature repeater. They're very reliable. It's an 820 Kenwood. You can't buy them anymore. Everybody's gone to digital now. And but I had a little 820, which is a little desktop, and I don't know if this is interesting or not. But when you do digital mobile, such as D-Star DMR, your frequency has to be really top rate. It has to be precise, because any drift, because it's narrowband, any drift will really affect all those little ones and zeros going through the air. And it would get cold up here and it wouldn't work, and it was because the little ticks. I just didn't have the ability to have the stability on the frequency. And these do a lot better job, so I have to come in the winter and adjust the frequency on it.
All right, this is the one of the receivers for a 6-meter repeater. Yes, we actually have 6-meter repeaters, and I've worked some DX stations. I've actually worked a station up in Pennsylvania and New Jersey on this thing. And essentially what this is this bottom one is a receiver. It's an old commercial receiver. This actually came out of the old Benton County 43 megahertz fire system. And what happens here is the signal comes in from out on the tower on the antenna, and it goes in and out on this 440 radio, and it goes back out to the what we call the wash shack that needs some work. And essentially, there's another radio here that does in reverse. It comes out, goes through the controller and into the transmitter. And the transmitter is a 110 watt, pretty beefy thing. It's a Motorola Centaur X, almost said X9000. The reason why it's in this sort of form, not just like a one rack, is because the duplexers. You may notice there that we'll show you later some too. That there's these kind of small things, and they're a physical wavelength capture device, meaning that there actually has to be a physical wave inside there resonating. And at 6 meters, that will put them right at 6 or 7 feet or whatever it is. Huge devices, about the size of a fridge. And
so John, you can look at a duplexer probably and how tall it is and tell what band it's on.
That's right, absolutely.
Okay, all right.
And not only are they getting to be rare because a lot of the public safety has long since left the low band FM. They're also very expensive because, as we'll talk later, these things are silver lined. There's a small little microplating of silver on the inside that's hard to get on there, and that just jacks up the price even more. Tim, why'd you put a bomb on the table?
Well, I have a friend that got in trouble by having one of these in his car, and they called the superintendent of the school and wanted to know what that was in his car. And I see why this was jumping around. This connector was loose.
Oh.
Now, what we have, we've been talking about the magic of a duplexer, and this is a single cavity filter, okay? It's close to a quarter wavelength in the 2 meter band, and also in the 155, 160 range too. This is actually a commercial one made by a company that unfortunately is no longer in business. In Waco, Texas, they were called Wacom. And they loved hams, and they gave us really good discounts. Now, normally a duplexer has anywhere from 4 to 6 of these babies, and they're all hooked together with phasing harnesses, and you get the net result of all 6 of the cavities. Now, we call it a cavity because it is a cavity, but just think of a duplexer as a filter. And what this does is allows us to transmit and receive at the same time. And the 2 meter band, that's a little bit harder to do because you've only got 600 kilohertz of separation between the transmit and receive frequency. So that's quite a challenge to be able to hear that tiny little voltage coming down the antenna while you're spewing out, 50 watts, 25 watts of transmit power. But through these little cavities, these filters, you can do it. Now what we have here, this cavity is laying down. Normally they're standing up. What we have is a spectrum analyzer. This is a Hewlett-Packard service analyzer. It was actually designed for TDMA base stations, but it's got what's called a tracking generator and a spectrum analyzer built in. And what it does is you set your frequency. We've got it set down here, our center frequency. It's where this little dot is at 146.700. Now where was that repeater? Up at Bradshaw Mountain?
No, that was right here on Dog Mountain many years ago. That was the old Northwest Arkansas Amateur Radio Club.
Okay.
It's still in the air down in Elkins.
Well, the guys that's been around here, and some of the old timers, as we call them sometimes, may remember this frequency. Now, this has a negative offset. Now, remember, we're talking the repeater, not your transceiver, because everything's reversed, if you will, on your transceiver. But we're looking at this little flashing dot. Now, when I turn this dial on this duplexer, this knob, watch that little thing move over. Now, at the same time, we're watching that little curve. The level of loss, this is measured in decibels. Okay, right now it's minus 2.27. Now, as I turn this knob on here, which is a little plunger that goes inside this cavity, we're getting our number down and down, and visually we can see it getting more centered, and lo and behold, we have 0.68 dB of loss. Now, that's understandable, and this is what we call the insertion loss on a filter. Okay, so we're going to lose 0.68 of our receive or our transmit signal, but that's okay. That's a cost you pay to be able to get to be able to transmit and receive at the same time. Now, this is called the reject stub, and once again, this is in a little cascade of 4 to 6 units. Now, I'm going to change this to the actual. This is actually the receive frequency of the
transmit frequency of the repeater. It would be
no, this is actually the receive frequency, is it not?
That's
on the repeater, but on your radio.
On your radio, that's receive. You would listen to that, and you would go down 100.
Sorry, everybody. John has to set me straight. I'm getting feeble. He's got a young mind, and he's dead better. John is absolutely correct. This is the transmit frequency on the repeater, which will be your receive frequency on your radio. Okay. Now, this is called the reject stub. Now, what we want to do is we want to get that 146.700 out of the, what is it, John? It's
146.
146.1. Enter. Okay. Now.
You put that in on the span.
Sorry, everybody. Hold on just a minute. What I have it at?
5 megs, yeah.
Yeah, I need to learn how to use my equipment here. Sorry, guys. I did the wrong thing. So, it's 1. 46.1. Enter. Okay, now you can see our little dot right there, and it's negative 14.
But we want to try to get it down there in that little
That's
notch, right?
right.
Yeah.
So what, this is going to be the transmit, this is the receive, and we want to separate these and filter them out the best we can. So what we do is we move this little rod right here, and this was a little patented device that Wacom had, and we should be able to get that. Now notice we're dropping negative 18, negative 20, negative 30,
32.
negative 32. Okay, now normally what we would do is lock this down. So we have got we've got 32 decibels of isolation now between the receive frequency and the transmit frequency. So if you get two of these put together, you're going to double that. And you would have two cavities for the transmit and two for the receive. And this is how easy these things are to tune. And like I say, I know I keep using that word, but it's like magic. So this is a 2-meter cavity, and we'll look at the trace in a few minutes here on a UHF cavity. We won't tune it. It's already tuned up, but I'll show you what the curves look like on it. So this is how we filter the transmit from the receive.
And to give you an idea about what that 32 number means, I believe it's 30 dB is like the difference going from 1 watt to 100 watts. So if you have, say, a 100 watt transmitter going into this filter at this frequency here where we're notched to, this 146.1, by the time it comes out of the filter, it'll only be 1 watt. It's minus 30, it loses 30 dB, and that's what that sort of means there.
That's right. You keep rolling.
Yeah.
Every 3 dB is a double of power, transmit or receive. And,
Or loss.
Or loss, right,
Yeah.
right. It doubles it. So, you can imagine 30 dB, how much separation that is. And then, of course, with another cavity, it's going to be even better than that. Okay, now we're going to take a break. We're going to hook up a UHF, an actual whole duplexer that has all the cavities. And you'll notice that it's much smaller than this VHF cavity.
Now, Tim, when most people talk about a 4-pack of cans, it's usually Miller coming out of a store. What are these cans?
Well, that's not computer, but repeater nerds call these cans too. And this is a 4-pack of cans. And we looked earlier at just a single cavity filter that was in the 2-meter band, or VHF. And what we're looking at now is, you'll notice they're much, much smaller compared to this guy right here. And that's because of the wavelength, much higher frequency in the 440 band. These little knobs right here are the pass, and that's how you adjust the pass. And these little knobs right here are the same thing, but they're both sides now. These are labeled. This says 442.075. So this is the repeater output. This is the transmit frequency. And by the way, these cans used to be in Silent Springs. This one says 447.075, which is the receive frequency. So, on this one, when we adjusted the reject on it, we had this kind of slide trombone affair. On these, there's little capacitors, and I'm not going to open them up, but these are little caps, a literal cap, like a cover, and that little capacitor is in there, and that's how you adjust the reject frequency. So remember what we want to do. We want to pass the transmit frequency, and we want to reject the receive frequency the best we can. Now what we're looking at, these have been pre-tuned, and this is kind of a funky curve on the pass. Normally it should be a point, but for you tech guys like Steve out there, you're going to say that's not very good. And we think that these cables on this thing are not the correct length. This is a kind of a second hand. But what we're looking at on the spectrum analyzer is 442.075. And for the users out there, that would be their receive frequency. But on the repeater, it's the transmit frequency.
That would be if you say, "Oh, I'm on the 443.175 repeater." That's
right.
That's what you would be tuned to.
Yeah, we always talk about the transmit frequency when we talk.
Transmit of the repeater.
Yeah, of the repeater when we talk about the repeater frequency. Okay, now you'll look here, and the level is minus 2.22. So in other words, the insertion loss on the transmit side of these two cans, this is the transmit section, this is the receive section, and the combination of these, we're getting that much loss, which is acceptable. Now here's where it really comes in. You see this deep notch right here. I'm going to tune to it, which is the transmit frequency. Hopefully I'm not
Of the
getting
user.
that. Yes, of the user. And I'm also going to expand the reference level because that's so far down in the noise, we really can't read it.
That's what makes it so thick, all that
Yeah,
yellow stuff.
yeah. So now on this same side that the transmitter is hooked up, look at this, minus 93 dB. It goes from 3 to 4 to 2. And look at that deep notch. We had to change the reference level another 20 dB just to get it up out of the noise. So that's how far the receive and the transmit are separated. And actually, it's the same thing on the receive side. When we go to the two cavities on the receive side, we'll have that same thing. So in other words, between all the cavities and everything, we'll have as much as 85 to 90 decibels. And remember, that's logarithmic. Every 3 decibels is a double in power. We'll have that many decibels of separation between the transmit and the receive on the repeater that we can literally transmit and receive on the same antenna, and that big 25 watt transmitter won't affect that little 0.25 microvolt signal that's coming in from a user, and that's the low level. If you're stronger in the repeater, it'll be a little bit better than that. And it can do it without any desensitization. In other words, the transmitter won't affect the receive signal at all. So this is kind of the magic of the duplexer. You just have to have them. It's possible to do split antennas. Let me show you another one real quick. I call these a mobile duplexer. Now, what these are just reject only.
Meaning they only have this pointed
Right.
down characteristic. They don't actually have the
Right.
bump that comes up and rises.
Right. They don't have the pass. The nice thing about the pass is it filters out on the transmit and the receive side a little bit of spectrum there that's close to the transmit and receive frequencies. Those get filtered out because of the way the curve goes on the pass.
And that's really important up here at some of these bigger, larger tower sites, because you may have, I don't know, a sheriff's office, a fire department, and a ham UHF repeater. And if it's one of these only notch type duplexers, you can easily hear anything that's not tuned on that notch. That notch is only for the other, like say in this instance, it notches out the transmit frequency.
Yeah, exactly. And these little things work well, but I prefer the bandpass band reject. I know John does too.
Yeah. Just to inform, the best that we've gotten out of these are like minus 75. I think we might have gotten minus 81s out of them.
Mm-hmm.
But minus 70 is pretty typical. These originally came from out of ambulances running patches to hospitals so they can have duplex audio. So literally like a phone, you could talk and receive at the same time. And they're pretty popular on eBay. And thanks, China, $100. And Tim, what would you say one of these go for?
Well, if you buy a new set and not on eBay like I usually do, you can pay. You should be able to get a good set for about $600-700.
Yeah.
But you have to be careful, especially on the VHF duplexers, because most of those are made for the commercial bands, which get to enjoy a split of gosh, as much as 2 megahertz
Or more.
And on the ham bands, our split on the VHF is only 600 kilohertz.
But 5 on UHF is typical, even in commercial.
Typical, right. And in UHF, it's always easy to remember that the transmit is always the low side and the receive is always the high side.
In the large majority of the U.S.
Right.
Not everywhere.
Right.
And it might also be noted that these have little capacitors in here up in these upper sections. And you run much over 50 watts in those, and they really start getting physically warm.
Yeah.
These, especially with 100 dB of isolation, you can easily run 100 watts, and your receiver won't even know that transmitter's there. So
Well, I think we beat everybody to death about duplexers, John.
Oh yeah, I think too.
Well,
I love filters so much.
Yeah, filters are awesome, especially when you've got a spectrum analyzer, and John's got one too. And you can look at them and tune them, and there's so much magic you can do. And that's what I love. My favorite part of repeaters is the RF part of it. The digital stuff I'm not real sharp on, but I can do some of it. But I just love the RF aspect, and have a spectrum analyzer to actually see what's going on in the RF world. It makes things make sense, especially for people that are visually oriented like myself. So it's wonderful happening. Okay, well, that's enough about duplexers.
So this is a typical repeater controller. Well, I actually guess it should be positioned like that. This is one of the cheaper controllers. Hey, watch that password, 1234. This is like a $150 controller off of eBay, although this one's rather old. Essentially, most repeaters on the NWA Link system utilize what's known as a CAT controller, which unfortunately just came out of business in 2019, something like that. Yeah. But anyway, pretty much any controller on the NWA system is a dumb controller. All it does is it handles for audio coming in and out of the same port, and also a little signal like your PTT, like pressing the mic. But there's also this other little port here, and these are old, actually, serial connectors. What they do, this is called the link port. And if you go into any of the repeaters, not Mercy, that's the only exception, there's this link radio, and it's a radio program just like any other user's radio. And what it does is it takes the repeater, like say Kessler Mountain 442.0 it takes that audio that it receives and transmits it out locally on 442.0, and also sends it back to Mercy for the rest of the world, the rest of the link system to hear. And that link is what makes it a linked system, and we can actually pass traffic and audio between the repeaters and connect them together and tie them together. And a lot of commercial public safety stuff is kind of moved from this. It's starting to be a little bit of a dated method of connecting repeaters. A lot of them switch to like trunk systems, which is just, I think that's way too complicated for amateur stuff. I can't even wrap my head around it, although I'm not that bright anyway. But these controllers, to make a long story short, come in different shapes and sizes. This one I've had at Huntsville for a long, long time. That's why it's dusty and nasty. This is actually mounted on a old radio cover, a Motorola MaxStrap cover. And they have these. The RLC is currently the one up there. Green Forest runs what's called an RLC, an Arcom 210, RC210 controller. And it has fancy voice and stuff like that that's more modern. And this right here doesn't do any voice at all. It just does CW and Morse, and for the most part, that's fine. The controller at Mercy, is it the built-in one into the kit?
It's the built-in, yeah.
Right. So there's not an external controller. A lot of repeaters like the Kenwood, like what you just saw, was just do have an internal controller, but they're very basic. They wouldn't support linking, or at least most of them do. If you've ever seen like a Bridgecom repeater, if you ever looked in the back of QST and the guy's really pushing 220, those have very basic controllers, and that's it. But me personally, Tim's into the big digital voice D-Star stuff, and of course we now got the DMR repeater up here. But I'm big into All-Star, which isn't a digital mode. You can use any analog radio, and what it is a Raspberry Pi computer takes the place of this, and it gives you what's the equivalent of an SCOM, which is a $1,000 controller for free. Well, pretty much the price of a Pi, which is $30. And you can have digital, or you can have analog voice go over the internet, connected to wherever. And like up here, my 6-meter repeater is connected to All-Star, to the All-Star node up in New Jersey, which is node number 27233. Think of it, it's like a modern Echo Link, but Echo Link's, getting old. It's designed for people that want dial-up. But this All-Star stuff, you can use your handy talk, your mobile, and just talk on it normally like an analog repeater. If you have a radio that'll get in on the link system, you have a radio that can get in on All-Star. So I'm up here at what used to be the transmit antenna. Now it's the receive antenna for the 53030 repeater. And you get some size perspective of this thing. It's easily goes beyond my head. I'll stand up straight here. You can kind of see I'm a little bit over half the antenna's length. Granted, it is up other way, but essentially, don't let it fool you. It's a dipole. It looks really complicated, but no, it's a dipole. There's a special jumper called a quarter wavelength matching line, and as you could probably guess, it's a quarter wavelength. And what it does is, when normally a folded dipole in free space is 300 ohms impedance, when our coax is 50 ohms. So how are we going to get that down lower? Well, the guys over at DB said, well, let's see what this impedance is like right up against the tower face. So they did that. Now all of a sudden it's 100 ohms, and it's perfect for a quarter wave matching section, which matches a 50 ohms to 100 ohms with all but a length of just 75 ohm coax, and that's all this is. It's just a really big, thick piece of what you run for your TV of 75 ohm coax, which it looks like we need to do some strapping of that. But there's a pair of these. This is the receiver, and the transmit one's way over there at what we call the wash shack. And essentially, because the duplexers are so large, we can't get enough isolation. So what we have to do is actually physically move the antennas. And we go up on 440, come back down on 440 over at the transmitter, and we'll bob your uncle. Then you have a 6-meter repeater. And we're going to hopefully someday install multiple receive sites just like this. We have one currently at Montanay, thanks Dennis, KA4AFE. And how you'll access that is right now, instead of using a PL tone of 97.4, you simply just use a PL tone of 88.5. And I have a few plans, like I'd like to put one up at Green Forest with a PL tone of 110.9. So it's really simple. It's just two radios sandwiched together. It's nothing complicated at all about this 6-meter stuff, and you can work DX. As a technician, when the bands come open in the summertime, you can work nothing but DX sometimes on 6 meters FM. As you can see there, Tim's panning up and down the whole tower. Way up there at the top, we have the D-Star antennas. Well, it used to be the old 444.7 W5AWX repeater, which is now D-Star, or I'm sorry, DMR up there at the wash shack. You can see here, the run between my legs, maybe kind of hard to see from that angle. You have these great big old huge 7/8 inch pipes we call coaxes, well actually heliaxes rather. And you may notice something, I'm up here. Here's a little bit of a quiz. Do any of you notice what I'm doing wrong right now, other than being crazy out of my mind doing this tower climbing stuff at such a young age?
I know what you're doing wrong.
What's that, Tim?
You're not wearing a hard hat.
That's right. Guess he forgot his hard hat at home. So you should always climb with a hard hat and don't do what John does. All right? That's one thing. Also, you'll notice some of these, the best clamps and the way to hold this V-line to these great big old towers. Now, you got to imagine this stuff isn't the lightest stuff in the world. You don't want this stuff coming and blowing loose on you during a storm or something like that. They take a piece of Romex, which is just a piece of, I should say Romex, but 18 gauge or not 14 gauge wire, and they'll wrap it around it and twist tie it. And that's one of the best clamps. They have real clamps, but I've always found they come loose, and they cost about $3 or $4 a pop. Anything you'd like to add to that, Tim?
Nope.
Nope.
Be safe coming down, though.
I will. You probably can't see it, but right there where I'm pointing up across to the other side of the tower, we have what we call a, is it nano bridge or nano station? The little white microwave router.
We won't be able to see it, but you know what we can see, John?
All those dishes up there.
We can see our little microwave dish that points towards Eureka Springs.
Hey, and all that's Part 15 Wi-Fi. You'll be a hand feeling that stuff.
Let me back up a little bit, and well, you can see some of the DP224s way up there, and this tower's only, gosh, what, 150 feet?
175 with the top.
Yeah, and there's more dishes up there. One that goes to Eureka Springs, one that goes to my house, and then the one that goes to Winslow. Okay, John, we'll be safe coming down.
I will.
I hope you have found these presentations enjoyable and informative. Thank you for being a participant. I invite you to stick around after the meeting and join us for a Q&A roundtable about tonight's presentations. You do not need to be a member of BVRC to participate, but you must be a licensed amateur radio operator. We will be on the air using the NWA linked repeater system beginning at 8:30 p.m. local time. For information on the link system, go to nwalinksys.org. That's NWALINKSYS.org. Your comments, questions, and suggestions are welcomed and encouraged. Please address these to info@bellavista.radioclub.org. That's info@bellavista.radioclub.org. Also, for more information on the Bella Vista Radio Club, visit our website at bellavista.radioclub.org. We invite you to be a member of the largest amateur radio club in the Northwest Arkansas region. We exist to serve the amateur radio community. For now, I'll say 73 and stay safe. Good evening from W5XNA.